Hello, welcome to Uncle Solo's problem solving classroom again. That is my contact, phone number and email. Just let's link up, let's solve problems. Practice makes perfect. Okay, let's do some linked thinking. Here's today's challenge. We have if y to the power a squared over y to the power b squared equals y, and a plus b equals 2, what is the value of a minus b? Okay, if you can, try it. If not, let's do a quick review and then let's try and solve this problem together. Okay, so here we have some laws of exponents, or in the UK and elsewhere, they say laws of indices. Okay, if we have a number a to the power x, number a to the power y, which is the same base, okay, this here, a is the base, and then the x is the exponent or the index. Okay, so if you have these two numbers multiplying, all you do is just add the exponents. So a to the power be a to the power x plus y, 2 to the power 3 times 2 to the power 2 be 2 to the power 3 plus 2, which is 2 to the power 5. And that is 32. Note, 2 to the power 5 is not the same as 2 times 5. This is 2 multiplied by itself 5 times, and that is 32. Okay, if I have two numbers dividing, okay, the exponents, the same base, I just subtract the exponents. What is 2 to the power 11 divided by 2 to the power 8 is the same as 2 to the power 11 minus 8, which is 2 to the power 3, and that is 8. That is 2 times 2 times 2 is 8, not 6. Okay, the number to the negative exponent is 1 over the number to positive exponent, and here is an example. Also, if I have a to the power 1 equals a, okay, always a number raised to the power 1 equals the number itself. We know that. And if I have a to the power x equals a, that means x equals 1. Same base, so exponents are equal. For example, a to the power 3, if a to the power 3 equals a to the power y, since same base, they're equal, that means the exponents are the same. And I will say y equals 3. So keep this in mind, we're going to use it. Okay, if I have a to the power x equals a, then x equals 1. Okay, here. What if I have two numbers like 27 squared minus 23 squared, and I say evaluate this without a calculator? Okay, we apply the technique called difference of two squares. X squared minus y squared is equal to the sum times the difference. So here, without a calculator, you're going to do 27 plus 23 times 27 minus 23, which I think I made a mistake here. It is 4, and this will be 200. 200. Okay, let's do some more examples here. So I have, without using the calculator, I say evaluate this expression over here, and I say 5 to the power 3 times 5 to the power 8, okay, divided over 5 to the power 7 times 5 to the power 2, 5 squared. So what do? Okay, you apply the laws of exponents. First, the top is multiplying, the numerators are not multiplying, so what? You add the exponents. You do the same for the denominator. Okay, then you kind of apply the next rule, which is when they're dividing in the same base, you just subtract the exponents. Okay, and you end up with 5 squared, which is 25. 5 squared is not the same as 5 times 2. This is 10, this is 5 times itself. Okay, now try this. Okay, try this. First apply the first law of exponent to the numerator and denominator, then do the second one, and you should end up with 10 squared, which is 100. Okay, without using the calculator, evaluate 100 squared minus 99 squared. What do you call it? Difference of two squares. The sum times the difference. Okay, the sum is 100 plus 99. The difference is 100 minus 99. That's your answer. Okay, try it. And here, if I say two numbers are multiplying, x times y equals 39. If I give you one of them, then what is the other? Okay, just follow the steps. You divide. It means y equals 13. Okay, now here's a summary of what I just said, and that's what we need to solve the problem. Is when I have dividing exponents, a to the power x over a to the power y, just subtract the exponents. Difference of two squares, a squared minus b squared equals a plus b times a minus b. And of course, this one here. And then finally, if a to the power x equals a, okay, remember there is a 1 here, but we don't write it. That means x equals 1. So if I write y, it's the same as y to the power 1. Okay, same base. That means exponents are the same. Now, okay, review everything I've done here, and I say now link it. Be analytical, okay, be bold, and exhibit perseverance. Okay, so what I've seen over and over is, okay, students, good students who make an A here on this topic, they master it, they make an A, okay, and then they make an A here on this topic, okay, they make A here on this topic, A on that topic. Now, here comes a problem, okay, there's a question, they've not seen it before, and they fail to do the link thinking, they fail to do the right thing, and that is what I want to teach my students, link thinking. Okay, so here's the question. Pause the video, try it first, okay? Applying the laws of exponents and the other algebraic manipulations that I just taught you, and then try the problem, okay? Before you watch my solution. So here we go, we have y to the power a squared over y to the power b squared. Okay, I say this is equal to y, and remember there's a 1 here. Okay, first, laws of exponents. This becomes y to the power a squared minus b squared is equal to what? Y to the power 1. This whole thing is that one. Okay, well, next, what do you say? The same base, so the exponents must be the same. A squared minus b squared equals 1. Okay, then what? Next is what? Difference of two squares. A plus b times a minus b is equal to 1. Cool? What have you been given in the question? They say this is 2. So 2 multiplied by a minus b equals 1. Then the final question is, what is a minus b? A minus b, how do we get it? We divide both sides by 2. So a minus b is equal to half or 0.5. There you go. That's your answer. Okay, what about this one? Try this one here. If 3x minus y equals 3, what is the value of 3 to the power y over divided by 3 to the power 3x? I'll give you a hint. Hint, if a minus b equals 10, then b minus a equals negative 10. And also remember, a minus a to the power negative x is 1 over a to the power x. What is the value of this based on the information I've given you? Okay, pause the video, solve it. Which one is the answer? Then look at the solution. All right. Again, this is Uncle Solo working with students. We're going to be solving problem all the way from now on throughout the summer, preparing 10th grade students going to 11th grade for PSAT 11, working with 6th grade students going to 7th grade, and Algebra 1 students. Let's solve problems. Okay? All right. Okay, apply yourself very well. I'll do my best for you. And all things being equal, you will what? Bloom. Let's link up. Okay, you have a great day. Bye-bye.